Hello, welcome to this tutorial. Today we'll be going over how to set up the Polygon ID self-hosted issuer node, and with it we'll be able to learn how we could issue verifiable credentials using Polygon ID. Well, let's begin. I'm sure some of you must be wondering, what exactly is Polygon ID? Polygon ID is an identity infrastructure that facilitates trusted and secure relationships between apps and users. And the primary problem that Polygon ID solves is that we are basically restoring ownership and control of your personal data back to you. Now, if you think of the current iteration of the web, a lot of people do not actually own their data and they do not own their accounts. Whoever it is that actually owns their accounts could easily like deplatform them off of social media. A bank could shut down your access to finances, and a host of other things could actually happen to you because we have centralized entities that essentially control our data, and they essentially control how we actually transact and do business and communicate online. Now, with self-sovereign identity, we are basically pioneering a brand new model for managing digital identities in which businesses and users have sole ownership over their accounts and over their personal data. And this is a revolutionary new approach that has been picking up a lot of momentum, but essentially we want to be able to restore a lot of control back into the hands of the users. And with Polygon ID, we have privacy by default. And so by that, we basically mean that we enable trust issuers to connect with trust verifiers. And we'll be going into how that happens here, because at the core of the Polygon ID solution is the triangle of trust. And the triangle of trust is comprised of three primary entities. We have an issuer who basically issues a credential. So you could think of this as a college or university that issues a degree to a particular degree holder. And the holder would then get that particular credential, and they would hold it inside of their wallet or inside of a safe or something of that sort. And then the holder would then go and present it to a verifier. And the verifier could be the HR at their new job. It could be a website that, it could even be another educational institution that is basically assessing them for whether or not they want to do a master's or a PhD program. And so somebody else could actually come in there and begin to verify to find out that information. The way that this works currently is very manual. If you just use that whole college analogy, but if we use Polygon ID and if we use self-sovereign identity, essentially we could be able to issue verifiable credentials. And the beauty of this is that we could use zero-knowledge proofs that could hold the authenticity of information without divulging the specific information. And why that would be valuable is that if you think in terms of bias, in terms of jobs hiring and ageism, imagine if you could be able to state that, yes, I do have at least 5 years experience since I graduated, but you don't necessarily have to show how long since you actually graduated, which means that the person reviewing your job application could have confidence in the fact that, yes, indeed, you do meet the minimum requirements, but they don't necessarily, they wouldn't be biased against you because they know how old you are. So those are some of the interesting primitives that we could begin to explore with the Polygon ID identity infrastructure. So let's begin. We begin by setting up the issuer node. And the issuer node is essentially a Go application that we could actually run. It's an open source repository, and this is the URL to it. So you could come in here and you could get more information. And as we scroll down, you'll see we have a bunch of different files, and there's a full guide here that you could use. But basically, we'll be using the Docker setup guide for us to be able to get started. So let's begin by cloning this repo, and we could copy that and provide that here. So let's begin by cloning this repo into a folder that we created here. So as we're waiting for the repo to clone, it's just good for you to be aware that we'll be using the Docker setup, and you should have Docker installed and should have sufficient space to download a couple of images that we will be using. And we're done. Now, once you're done, let's start by CDing into the folder that we just pulled down. And you could see here that we pulled down the full application. And there are a couple of things that we could begin to review, but let's review them in Visual Studio Code. So I'm just opening that whole file in Visual Studio Code, the whole repository. And the primary files that we want to be able to change, specifically in this tutorial, we're just focusing on the configuration piece. And we want to just change these three files here. So we have the env API file, the env issuer file, and the env UI sample file. And that's all we kind of need to be able to make changes to for us to get started. So let's begin. Let's first copy those particular templates. So I'll start by copying the env API here, and I'm copying it into a new file that's just env-API. And I'm doing that for the env issuer as well. So I'm copying that into an env issuer. And the env sample, right? So now that we have those three applications, well, we have those three files that we've copied across, we could actually get started here. So I'm just going to run a make up, which essentially sets up the Docker containers with the base information that we need to have. But before we do that, let's look into the env issuer setup. Specifically, there's a couple of things. The main thing here we need to change is that we need to provide an RPC URL. So on line 16 of the env issuer file, and we could change this later on. But we could start by ensuring that we have a URL here that's available. And I'm using an RPC connection from Anchor, but you could use any other RPC connection that you like. And for the purpose of this tutorial, we're using the Polygon Mumbai network to issue all of our on-chain credentials, and all of our DID, all of our decentralized identities will be issued against the Polygon Mumbai network, just because we want to use a testnet. And yeah, that's the primary thing we need to be able to do. And we could run make up here again. And that's it. All right, yeah, so we already have an instance of Postgres running. Let's give us a problem. But essentially, we already have an instance of Postgres running here, and that should. But on your end, when you're running this for the first time, it'll take some time for us to pull in these particular images. But if you're on a Docker PS, you'll essentially see that we have. Okay, I have a bunch of other things running, but let's review what we actually created. So we have a vault that's based on HashiCorp, which allows us to store different bits of information securely, including your verifiable credentials. We have a Postgres database that we're storing the information on persistently. And then you have a Redis cache that is just there for performance and allows us to be able to quickly read cache information that is stored in the database. And yeah, I'm just going to clear here and we could keep going. So the primary thing we need to do now is we need to add our private key. And to do that, we need to be able to run the command make private key and then provide our Ethereum private key. So how do you get that? Let's come into MetaMask here, and I'm going to have to log in here. And if you have Testmatic in your account, that's ideal because it means you could publish on-chain credentials easily. But for you to get your private key, just click on the three dots here at the top, account details, export your private key. Ideally, you should never ever show anybody your private key, at least for assets that you care about. This account is a throwaway account for me because I use it for tutorials. But try not to show or give anybody your private key. So back to terminal here, make private key, and you could provide that and then just add the command add private key, right? Add dash private dash key. And so the data is then written, and you could see that it says that, yeah, it's been successfully executed. From there, we want to add a vault token, and the vault token is what is used to sort a bunch of other cryptographic proofs that we'll be generating. So if you go back to the env issuer file on line 32, you'll see here we don't have an env token that a stored token that could be used for the vault. And if you run this command, make add dash vault dash token, it automatically copies it. And if you go back to the same file now, you'll see it's now on line 32. That particular key is on line 32, and it has a provided key that we could use. Yeah. And now we want to generate an issuer did. And the issuer did is just designed to give us an instance of an issuer that we could use against the UI. Now, from this point onwards, you'll see me using -arm on certain commands. And if you see me do that, the main reason I'm doing that is because we want to be able to target the Apple M1 and M2 chips. And if you're using an Apple M1 or M2 chip with a brand new architecture, then you need to be able to target your specific configuration, and so you add your -arm. But if you're not using an Apple M1 chip, then you could just take that out, and this should still work. But for my instance, I absolutely have to use that. And this essentially starts and creates a brand new issuer, replaces an old one, and then provides a issuer did. In the env, the issuer did is now added to env.api. Yeah, and that's it. So now we have created an issuer did, and from there we could start to run the application. So make run -arm is what we're going to be running here for us to start the self-hosted issuer node. And boom, that's it. Also we need to do, so we've added an issuer API, and we've added another container called the pending publisher, which will store some of our information that we'll use. So how do we test it, right? And check if the application is running on port 3001. And that's it. We have an instance of the Polygon ID self-hosted issuer running on our server, and that should enable us to get started. If you want to be able to run commands to it, you could actually, issue requests to the service that's running. On line 10 and 11, you have the username and password that we would have nominated here. So just head on over to password there, set in the password, the username that we identified. And once you do that, we could test it. So let's start by creating an issuer. And that's it. We have our first did that's been created, and that's available there. And let's use this as a sample, run that again. And this is our second did that we could actually begin running. Right. And let's create a claim. So we could create a claim against that first did, and we issue it against the second one. And from there we click try. And that's it. Here's our claim ID that we could continue on with. But this essentially shows you how to get started with the API application. In a subsequent tutorial, we'll be going through the full setup of how to use the full issuer node to issue claims, to create claims, how to generate the claims, create QR codes, and so on and so forth. But this, I hope this was helpful in helping you get started with Polygon ID. And if you want to learn more about Polygon ID, there's a whole YouTube series on Polygon ID here that goes through the various configurations and setups of how Polygon ID works. So yeah, thank you very much for joining, and I hope this was useful.